very much. So hello, everybody. I'm currently calling you from Italy. I will share a few slides with you. And the big story here is about a new kind of artificial intelligence, which is AI for AI. It means that we take one AI system in order to build other AI systems. Now, this may sound very scientific or like science fiction, but actually it has a very big and concrete meaning for our everyday work because the effect of AI for AI is changing the economics of the process of AI R&D. So whenever we would like to provide our customers or to build some kind of AI system, my suggestion to you in this talk is to do it through an AI for AI system, because the economics is better, it's cheaper and faster, and etc. So the topic of this talk would be how generative AI, the new kind of AI that generates something, that creates something, can enable data units in different organizations to become AI factories, to become bodies that produce, that make AI. Okay, so this is a short glimpse of our company. We are a startup company in Israel, but something like a third, maybe more than a third of our company is our PhDs, people with very large experience and academic experience in artificial intelligence. I would like to open with this nice slide that I just encountered from a verdict that tells the story about the new kind of artificial intelligence, generative AI, where an AI create content. So we all know about it because we saw it. We saw it in ChatGPT that generates texts, generates content. We saw it in DALL-E, for example, and Midjourney, that an AI, generative AI, can create beautiful pictures. So when we started the company, we asked the question whether we can use AI, generative AI, not to generate content, but to generate AI. As I told you, we are a company with a great deal of PhDs in the field and a very large experience, and we wanted the generative AI to replace us. So we were data scientists. We did AI for many customers along the years manually, and we wanted some kind of a generative AI that will that will replace us. So you can see that this is the new source for this nice slide by Evolution. This is the name of our company. All right, let's begin with the problem. We like to call it the aristocracy problem. Oh, that was an AI making some interpretation of my hand gestures. So despite the demand for AI, all over the world, so many companies would like to have AI. SI, system integrators, and ISVS service providers, service vendors find it hard to turn AI into a scalable arm. Again, I'm touching the economic side of it. So we want to become a scalable arm that can produce AI in a cost-effective way, in a profitable way. So the aristocrats in this field are those companies that we all know, like Amazon, AWS, OpenAI, Azure, Google, of course. But when other companies, the long tail of the companies, would like to become AI factories, they face several problems. First problem is that this is a really deep academic and scientific field. It's not very easy to get into that. The second problem is that we all know there's a lack of data scientists all over the world, by the way. Data scientists are not easy to find and they cost a lot. So it means that such projects, when we need to produce some AI, this project takes a lot of time and some great deal of money. Of course, because it is a scientific field, and we don't know what we will know when we finish the research in this science, there's a high risk. Many projects fail. Actually, current statistics, it's amazing. They talk about 50, 60, 70%, depends on how you measure it, of projects that fail, that actually don't go into production. And lastly, and maybe this is the most important element, is that we need, as data organizations, we need to provide a supermarket of goals. It means that not like Tesla that now wants to do AI for autonomous driving and that's it. We as service providers, we need sometimes to do projects in computer vision, and sometimes in natural language processing, and sometimes in prediction. So we need to cater for a wide range, a supermarket of different goals, and it is hard to do it when you have lack of data scientists and so on. So I would like now to suggest to you a different approach how to encounter such problem. And this different approach is based on an invention that actually happened 48 years ago. It's called genetic algorithms. I will show it to you. Genetic algorithms is a field in computer science and in artificial intelligence that tries to simulate the process of genetic evolution. And we provide a modernized platform for genetic algorithms for the purpose of automatic evolution of AI solutions. So, in order to understand how it works, probably you all know and you've seen jungles like this, slides like this of a competitive landscape. This is a classic competitive landscape of the field of data and machine learning. Everything you can find here. Abundance of tools in the field of infrastructure and in analytics and machine intelligence. Many different tools. Of course, a lot of open source. That's very important. And actually, with all this abundance, the work of the human data scientist, when he or she wants to build some kind of an AI solution for a customer, is to sit with the customer to understand more or less the challenge and the data, and then to build some kind of a solution, which is usually a pipeline of several tools. So you take a tool from here, a tool from there, a tool from here, a tool from there. The output of one tool is the input for the next tool, and so on. Each circle here, each tool can be a neural network or whatever it is. Never mind, there are many different kinds of tools. But my point is that only after you've built such a pipeline, after you work for several months maybe, to tie all the things together, only then can you really measure how well your solution is. So if you are a genius and from the first time you chose just the right tools and the right parameters and so on, that's great. But really, it usually never happens. So after a while, you need to make some change, a small change, a large change. You need to make some change, then test it again, measure it again, and maybe do a change again. So I don't know if you know it, but this part is the largest time of the work of human data scientists, to do trial and error and to test different tools and different algorithms and different models to the problem and data at hand. Now we have a different approach for that. We believe that computers nowadays, because they are much faster and stronger than they used to be, they can do this trial and error process automatically by artificial intelligence, by genetic algorithms specifically. And in order to explain how this magic can happen, I would like to show you a toy example, a very nice demonstration of how genetic algorithms work. And this is by the Mona Lisa example. As you can see it, it's a famous example. You can find it also online, where the goal is to redraw the picture of the Mona Lisa by a combination of circles. Only a small number of circles, 200, 300 circles that you need to glue one on top of the other so that you get what you wanted, the Mona Lisa. So each circle can be anywhere on the screen, in any radius, any size, any color, and any transparency level. Now think about it. How would you just ensemble them together so that you get what you want? Maybe you will tell the face in yellow, 2 for the eyes in brown, and so on. It will look like a very childish picture. And here the analogy is that these circles, they represent the tools and the different models of AI. So the question is how we make this ensemble optimal. All right. So if not by manual design, how can evolution, how can the simulation of the evolution process can do that? Well, we approach this problem by making a population of solutions. In this case, we have different pictures. Each picture is a combination of circles. So in our case, of course, it's not 25. Maybe we do 1,000 solutions, and it's not pictures. It's combination of AI tools, but you get the analogy. All right, so we have here 25 solutions, a population of 25 solutions that initially they are built randomly or by very quick and dirty means. So here we have 25 pictures with random circles. Question is whether these solutions are good, whether any of these pictures resemble the request, which is the Mona Lisa. And of course, the answer is no. They are random solutions, so they are all bad. However, they are not equally bad. Statistically, it's impossible. So just randomly, some will be just a bit better than others. So here you can see the best individual from the population. If I just compare pixel by pixel to the goal, to the request, the Mona Lisa, this is the best individual so far. And now comes the part in evolution of natural selection. According, to the theory of Charles Darwin, if you know, we kill the bad solutions. We keep only the 10% or 20% of the better solutions, and then we mate them. By mating, I mean that we create an offspring solution that was not programmed by humans, that shares some of the characteristics of a father and some of the characteristics of a mother, so-called. So just, randomly, probably most of the offsprings will be somewhere in between the father and the mother, somewhere in the middle. But some of them, even by 0.001 chance, solutions will be born that have the best characteristics from the mother with the best characteristics from the father, like happened to me, for example. And for this slight chance, it was the whole process. So now I will start evolution. This is the simulated evolution. This is the synthetic evolution. At the bottom right here, you can see the number of generations. So you see 1,000, 2,000 generations. Each generation, we create a new population of offsprings from the better parents from the former generation. Now, you can see that more or less the picture becomes more and more similar to the request, what we wanted, but not so much. Well, luckily, computers are very diligent and they can work 24/7. even on weekends and at nights, and continue to improve and improve and improve, do more and more trial and errors, and evolve a much better solution, a much better ensemble of this AI pipeline or circles pipeline in this example. Until we reach a point that we say, you know what, this is good enough. And we got really amazingly something that is proven, according to many scientific researchers, proven to be the optimal solution based on this number of circles. So in this case, I had only 250 circles. Of course, if I had more, it would be even more similar. But it is proven that genetic algorithms have the highest chances to find the optimal solution, the optimal combination of these circles compared to any other algorithm. So that is the idea. Of course, this is a very heavy, computationally heavy process, but this is a problem of the past. Nowadays, with the new kind of GPU processor and the cloud computing, this is totally possible. So as I said, it's an invention from 48 years ago, but it was like stuck in ivory tower of academia because it was too heavy. Nowadays, it is possible. So we created a platform that we call Earth, because Earth is the best place to make evolution, as we know. And you, as people that professionals that work with data, can use our platform, can use Earth in order to make AI solutions for clients. And I would like to show you real-world examples from really various different disciplines. Let's begin with the health sector. In Tel Aviv, Israel, one of the best hospitals, actually considered number 2 in Israel, is called Ichilov or Soraski. That's the main hospital in Tel Aviv. And they asked us to make an AI that will predict how many people will come to the emergency room each hour for the next week. So what you see here, these charts are actually, it's day and night, day and night, day and night. So during the day, more people come. During the night, of course, less people come. And what you can see is that orange is the prediction and the blue is the actual. And the top chart is like the before and the bottom chart is the after. What you see here is when we took their own system that currently does it and improved it with evolution. Now, 2 things I can tell you about it. One is that the increase in the accuracy of our ability to predict how many people will come in the ER based on tons of data. Of course, things like weather and information about what kind of diseases now run in the city, as well as even the television guide, because it is known that where there is a big TV event or a big football game, people are less sick and come less to the emergency room. This is a true story. Anyway, so the increase in our accuracy was immense. But the second thing I want to tell you is what you can see here at the right. These are the only commands that were used in order to make this improvement. So these commands were written by our scientists or our data scientists, which is nothing, right? Very few commands. And all the rest was done by evolution. Evolution, the process evolution, not just the company. Another example, StoreDot. Now we'll go to the energy factor, but still here in a manufacturing world. StoreDot, I don't know how many of you know it. It's an Israeli company, actually a unicorn. that produces batteries for electric cars with ultra fast charging. And for their own R&D processes, they needed a prediction for the lifetime of the battery, of each battery. So again, what you can see here is the before and after. And the prediction here is predicting the future, predicting how long each battery will survive. On the horizontal axis, you see how many cycles we predicted. And on the vertical axis, you can see how many actual cycles the battery succeeded to last. So of course, if prediction was 100% accurate, you would get all the different points. Each point is a different battery, all the different points exactly on the red line. It wasn't the case, of course, with manual data science, as they did before us. We just did this piece of code, which is again very, very small. And you can see before and after, the improvement was by hundreds of percents. Much big. Another big client is a very large electricity company in Israel. No, I'm kidding, there's only one. Israel is a small country. So the electricity company in Israel had a very interesting supply chain management challenge, where they needed from the logistic point of view, they needed to predict what products will the engineering departments will need to consume in order to purchase these products beforehand, and to keep the inventory in the storage between a minimum and a maximum amount. Of course, we don't want to run into shortage or to have a below zero inventory. That would mean delaying a project, an engineering project. But we don't also want too many products just lying in the storeroom. So the regular way of such companies, such large corporations to handle supply chain management, the main algorithm is called sawtooth. It's like a saw that if the inventory runs under a certain threshold, then you buy. And then it runs again low, and then you buy. So this is what you can see here in green. The inventory of a certain product goes below the red line, then there is a purchase order until a certain maximum. But the problem is that from the time that you make the purchase until the purchase arrives, it takes some time. And by this time, people still consume products. So many times you run out of stock and get into delays. So actually, it's a very interesting example, because this is a widely known all over the world. The supply chain management is a widely known problem. How can AI change that? Well, bring something new to we understood that they don't happen in vacuum. Some reasons for different consumptions. For example, if you say someone consumed a transformator, then you can deduce that on March, you would need to purchase wires, previous purchases. So you can just throw it to the machine, and exactly like what I showed you with the Mona Lisa, trial and test different combinations of products, of cause and effect. So this is what you can see in this animation. You can see on the left side the initial, the before of the sawtooth and how much shortages we had. And on the right side, you can see how the evolution, how looking for the correlations of cause and effect enabled the artificial intelligence just to push the criteria to purchasing just exactly between the bottom line and the top line. So that made a huge effect in the supply chain management of the electricity company. Now, I would like to show you an example which may look a bit niche, but it represents a much larger problem. What happens when we have a challenge and we don't have enough data? We don't have enough training data. So we face this problem in a company called Solel Boneh. It's the largest construction company in Israel. They fly drones above construction sites, mainly, of course, in order to monitor the construction, the progression of the construction. But they asked us, they said, you know what, if we already fly the drones, maybe the drone with an AI can spot safety hazards. That's very important. Safety hazards, they damage life, but they also shut down when there is an accident, they shut down the construction site for several days or weeks. So we created a system, we called it Finesse, finding safety events, that its goal was to find in real time hazard, to do hazard detections. As I told before, we built our solutions on top of current algorithms in the jungle of models and tools that I showed you. So in this case, we took YOLO and Coco. These are the best of the breed in computer vision. But here, the problem was different. The problem was not the algorithms. The problem was the data. Probably you know that each AI needs data to train, to learn from. So we needed here examples of safety hazards, of accidents. And the client told us, Solel Boneh, the client told us in a joke that they don't have enough videos of workers falling out from the roof, luckily. So we had and this is a very wide problem where you don't have enough data to train your AI on it. So in this case, what we created was a second AI system. We call it Bina, which is builders narratives. We used a technology from the world of virtual reality, of computer games and Hollywood, in order to create virtual construction sites. It actually means to create synthetic data. The idea is that you create with one AI system a lot of pictures of synthetic construction sites, and then you implement safety hazards inside them. And these are used as example for the first AI system to learn from. This is how it looks like. So for us, maybe it looks like a cartoon. It doesn't look very authentic, but for the AI, it's good enough. So we have this construction site, a virtual construction site. We have a virtual drone that you can now see, that we using the drone, we also simulate its flying. And you know, we can do it in day and at night, summer, winter, rain, above the ground, below the ground, all the things that we want to simulate. It's very, very easy. So we thought that would be great. We have here, like you can say, a waterfall that you begin on top with creating data, and this data is used as examples to the system that learns from the data, and then you get the real-time hazard detection. However, the results were quite poor. There were about 50-60% accuracy, and that was totally unacceptable. And this is many times the problem. We can do some work, get to some kind of accuracy level, but it's not enough for the client. So this is where the evolution part comes in, where we do like a reverse waterfall. The evolution tests and see where it failed in the real-time hazard detection, goes back to the top of the waterfall and changes the models that created the virtual data, the synthetic data from the first place. So in this case, we are talking about, not a metaphor, really, millions of virtual construction sites that were evolved, that were tuned in order to create the best training set, the best set of examples that will be authentic enough so the results will be great. And now you can see it in real life. This is a true construction site. And in this case, the example is to detect people without helmet, without safety helmets. So you can see the people here and here and here, they have helmets, but this guy in the back, he doesn't have the safety helmet. And of course, it works in real time. So as the drone flies, we get the detections of those workers with no safety helmets. Now, probably most of us saw here and there such computer vision and some object detection examples like this, but this is one of the few in the world that was trained on synthetic data alone. And this is really a very big breakthrough, and it means a lot in a sense of economics, because you can save a lot of time in making photo shoots of, in this case, construction sites, but of course, it can be of many other cases. Another example of, again, everything is the same. You see evolution, the creation of AI systems with evolution makes different use cases in different domains, but it's the same product, one single product. So in this example, I would like to show you something from the governmental sector. Here in Israel, we have an employment service, a very large employment service, that employees submit their CV, their resume document, and currently human annotators, they need to type in the CV information to a database. So the first challenge here was to make data from unstructured documents like CVs into structured databases. And this is a very large problem to do this transformation from a document where the information is unstructured to fields in a database in different tables. So what you can see here is a piece of a resume file, of a CV, that with computer vision and natural language processing tools, we were able to, first of all, do parsing. First of all, to take the different elements in the CV and identify them and to fill the tables of the employment service. That was the first part. The second part is to use AI in order to match each employee, each candidate with suitable jobs. And here, probably you know, there's a big jump, big breakthroughs in language models. And this is what we also did here. So once we took all the information from the CV file, which in many cases it's in natural language, right? And then using language model, compare it to job descriptions that are also in natural language. Here, everything is of course in Hebrew, but it can work in any language, and to make this matching. Now, this is how this system looks like, the system that is now being deployed all over Israel. in all the agencies of the employment service. It was a very successful project. And just to say that this matching is not done by only one model, but actually by 6 different models that all work in a symbiotic manner. You can see here each matching between a job and a candidate is quantified by 6 different metrics. You can say. So very similar to the Mona Lisa, we asked what would be the 6 different models, what would be the top 6 different algorithms that will predict the best job for each candidate. And the impact of this work was immense. Really looking very, very deeply into the texts that people write and getting knowledge about proficiencies and skills in order to make this matching. We are coming to the to the end, don't worry. So last examples, a very large company called Johnson & Johnson, probably you know. We work with Johnson & Johnson, not the shampoo division, but the medical devices division, where they had a very important or very popular medical device for heart surgeries. And many doctors and hospitals use this device and obtained tons of data about surgeries, about patients. Now, Johnson & Johnson is a very large company. They don't lack statisticians. All the information that was gathered among different hospitals and clinics from different doctors and patients and glue them together into one cohesive, different units, different numbers, different standards. And we needed, first of all, to organize the data. And this 3-dimensional cube tries to explain or to show how it is done, to glue together information about the demographics of patients, age, gender, ethnic background, and so on. With medical background, over time, how many heart attacks or other heart problems have accumulated over time. 3D imaging of the heart, so it's a different format, a different dimension, as well as historical information about former procedures and the approaches in these procedures, and operation analysis that was done at the end of each operation, and follow-up for 16 and 18 months after the operation, how many other heart attacks have happened. So this is example, of course, in this particular case, but my point is clearer. In many cases, you are not able even to handle such amounts of data with different formats, different ranges, different units, different standards, and glue them together. So you want some kind of automatic way to do so. But how would you know what is the best way to organize the data? It sounds nice. Yeah, I will throw all my data to the AI and the AI will know how to organize it. But how will the AI know what is the best way to organize it? Because probably you know, as data persons, there are tons of ways to manage the data and organize the data. Well, I can tell you one thing. If we have this AI for AI approach, we can ask it to try and organize the data in millions and billions of different ways. And for each of those organization options, run several statistic tests about phenomenon that we know, about medical phenomenon. So our understanding of the medical phenomenon is actually our compass that looks how to organize, or that guides us how to organize the data. So I will not get into the medical stuff here, you can see here, but these are medical or biostatistical tests that were done as an indicator if you organize the data well enough. And the evolution, again, it's similar to the Mona Lisa. The evolution here tried to organize the data in millions of different ways so that this statistical test that you see here, it's called Kaplan-Meier estimation, never mind, would be at the best position possible. So we use the statistical test of the medical phenomena in order to know and to discover what was the best way to organize the data. And lastly, this is the last example, is a solution for blind people. Well, blind people receive documents. There's a screen reader that just goes line by line and pronounce what he sees, what he reads. This is already a known solution, but it's not good enough for blind people because the screen reader doesn't know the context. And when you have financial documents or just bills from the telephone company with tables and so on, it gets confused. So there is an option to add in Acrobat PDF. There is an option to add transparent tags that guide the screen reader to read and to spell out the document with the context, with some explanations to the blind person about what he or she sees. But so far, this was done, the process of tagging documents to add those transparent tags was done by humans alone. Now, with this AI, we can change the mouse and keyboard of the person and the eyes, run the tool in the Acrobat PDF software, and do this tagging. What you see here is like a robot that does this tagging, that tells each part of the document what its type, if it's a paragraph or a title or a list or sublist and so on. This is a process that's usually done by people who see and tag this document for the blind people. But now it is done by this robot, by this AI that really replaces the eyes, the hand, the mouse and keyboard of the human tagger. And in the cases of table, which is the cherry on the cream, you need to really tag each and every cell to the corresponding title of the column and of the line. So fast forward, this is a very tedious work done by AI. So as you can see, really a wide range of AI capabilities in different domains, in different business verticals that can we did it all, and many more of them. We are a small team, all thanks to the evolution and the AI for AI approach. So to sum everything, let's compare again what was before and what is now. What was the old school manual data science process? It's like a puzzle, as I said. You need to take different elements, first maybe to organize the data, then to predict something. It's like a puzzle, and you need to pick the right pieces, glue them together. Usually it's hard, and it's a very long and tedious manual process. However, if you would like to take on the generative AI revolution, let's see how the generative way is to do AI by AI. For that, you need only three simple elements. Number one is to begin with a quick and dirty solution, like the first images that you saw of the Mona Lisa, something that is quick and dirty, even in some cases random. The second thing is using our system to write the business KPIs. You can just write it almost like in natural language, in a free-form way, you say what are the business KPIs of the end client, whether it's to make more money, to predict some future event, to cut costs, to whatever. All the examples I showed you now. So you just write it in natural language. And then, of course, you need some kind of a system, of a platform, in this case, Earth, that you can implement the quick and dirty solution that you made in the beginning, show this system what are your business KPIs, and then behind the scenes, all this evolution will happen, and a new generation of the AI solution that you built will emerge. So you see, now you have more pieces, more puzzle pieces. So the solution is bigger and better, but you can let the machine work again and again and again and create even more sophisticated human-like solution. And the system can work endlessly. So on weekends, at nights, and we can really push using the new cloud computing and GPUs, this process even further and create really much, much, much better solutions. Again, by stimulating the process of evolution, of natural selection, like our DNA was evolved during billions of years from the chimpanzees to what we are today, so we do it to AI solutions. And if you really compare the benefits from old school manual data science to the new AI for AI generation, first of all, it's much straightforward. You just say what you want. You just write in natural language what are your business KPIs. It's just straightforward. It takes less time, less money, lower risks. We have much higher success rate, more than 90% success rate than what is customary in the industry. Higher accuracy, in many times, the ability of those algorithms to fine-tune and optimize the pipeline of the AI is much larger than the one of humans, and therefore we achieve higher accuracy rates. And many times we get new capabilities that humans even could not have been. For example, the construction sites. You would not expect a human to write millions of different, to design millions of different construction sites. So just to say that AI for AI was just not possible 4 or 5 years ago. Like now all the stars are aligned, you can say. One important revolution was the cloud revolution. The second is the new GPU revolutions. And of course, the generative AI revolution. Everything happened more or less at the same time. So now it is possible, and you are welcome to do that. How does a process with a customer look like? Usually it has just 2 phases. We begin with phase 1, which is making this quick and dirty solution, rapid basic AI. This is usually still a professional service done by humans. We begin with sitting together with the client, making like a crack the case workshop where we try to think together about the challenge and how we want to address it. Then we set up Earth, our product. It means that we need to take the product, but connect it to the data, write the KPIs, and also design the structure of the output. And then we generate a rapid prototype. We have actually, Earth, the product has 3 different packages. They are more relevant to the second phase that you will see in a minute. They are small, medium, and large here. Small, medium, and large. I will touch it. Let's take the small package. Never mind. Tomorrow needs a report. And costs about $50,000. This is, but now, unlike other classic AI projects, we don't have to stop. We can let, and this is basically let computers improve, and also over time. Many times data changes, and many times reality changes. For example, in the medical examples that we showed, of course, the pandemic, the COVID, it changed everything. So now AI can be adaptive and change itself in order to respond to the changes in reality. So how this is done, this is phase 2. It's a subscription. And that's great. We don't need to work, right? We just sell a subscription that in each generation, we create 1,000 new AI solutions that are of the offspring of the former, of this prototype. We do a KPI-driven competition between the solution. And then the natural selection, we kill the bad ones, we take the good ones, mate them together, and make the next generation of 1,000 new AI solutions. And this runs 24/7 until a good enough solution is evolved and being deployed. These are the packages. They differ according to the kind of client, whether it's an enterprise client or high-tech client, and whether it's just a good start or something that is more classic. Depends also if you want just data organization or machine learning, or you need both, or you need some extra AI capabilities. But more or less, these are the packages and their prices that are of monthly subscription. No one needs to work, just let the Evolution do the work for you. So that's it. I hope you found it interesting. If you have any questions, of course, I'll be happy to answer. And if you want to contact me, so here at the bottom left, you can see my email address. And if you have any questions, I am here.
Thank you, Ronen. Thank you very much for your presentation. I would like to actually ask you a few questions, on behalf maybe our customers as well. So as we understand, because we have talked earlier also with you, you just download your data to the system, and the system will create the algorithms which is required by the KPI. And what you need to do is that to create some kind of requirements for the business task, and that business task actually will create the algorithms that is required by the certain request, right?
Yes, exactly.
Yeah. So what I would like to ask you is actually is that first of all, I understand that we can create another, online course with our customers by request. It's a first. We can show you the Earth, the platform as itself, because there is a platform. So there is access to the platform, so you can get the insight and you can see that. So what I would suggest, Ronen, is that we will collect the data, and then we will run some kind of on bi-weekly basis, some kind of sessions with the demonstration of the system, so we can see and touch the system and the software that we have done before, and to try to set up some certain KPIs and to solve it in the system, They create the KPI and then solve it in the system, and to provide it as a demonstration of the system at the online seminars. I would say it's not seminar, it's a webinar, So we will collect some, let's say from telco, people from telco or from banks or from retail. So we will create this kind of sessions. So what do you think?
Yes, I think this is a very good way to proceed. I think that I hope that everything I said was clear enough, but I can assure you that once you touch the system, it's very intuitive and easy to use. You'll see you'll see it in action.
I understand the impressions that the first time that we had with our customers here is that some of them are thinking something that what was that, how to use it. Actually, we met with the Ronald maybe 5 times, and then we clearly understand what is they are doing actually. And it's so easy system that you cannot even imagine. I mean, I understand that the first time maybe you will not, you didn't catch the idea, maybe. But I can assure you at the first or the second or third meeting that we will have with the seeing the system at itself and getting inside the system, you will see that how easy that is. Because some of you, they have a 50 or 70 data scientists, and you can imagine that you can reduce that amount, I mean, not amount, the work they do 3 times, 5 times lower range, So you can save lots of time, at the same time create lots of algorithms at the same time, because the algorithms depends on the knowledge, mathematical knowledge that your personnel have. Sometimes they don't have enough. But in this system, you can use the latest and the best practices that it's given by the system. They will find the algorithms especially for you. Because sometimes you may have some problems with the mathematical calculations that creates a problem inside the organization. So what we can do is that the Earth software will resolve these kind of complications that you currently have. You definitely have these kind of problems. And some of the banks, they have more than hundreds of data scientists, doing something. And this system will allow you to save lots of time, lots of money, and create this kind of additional value to your organizations in a faster way. And this subscription is a monthly basis. So that means that you can buy it for 1 month, calculate, make algorithms, and use it. In 3 months, you can come back again, use the platform, and everything is free. I wouldn't say pay as you go, but it's it's not so complicated as it seems, at this stage. What do you think, Ronan? Am I talking in the right way? I think.
Yeah, actually. Yes. You actually explained it very well. Yes.
Yeah, because I understand that there must be some kind of misunderstanding at the initial stage, because I also had this kind of feeling when we met first time, more than months ago. And so I made it clear for myself. So, and I understand that creating this kind of bi-weekly sessions would be great opportunity to demonstrate the system. Okay.
Yes, absolutely.
Okay, thank you very much. You were very excited. Your passionate presentation was great as usual. Thank you very much. Next time, definitely we will see you to demonstrating the system. And I am sure that this system will create, I would say, change the somebody's mind, as it did. Okay.
Sure. We'll be happy.
Thank you.
Okay.
Thank you very much.
Thank you very much.
Thank you, Ronan. Bye-bye.
Bye-bye. Bye.